we'll just quickly go through all of our hands-on projects. We'll show you the code and then we'll be done with that. Is that fine for everyone? And then after that, you all take us for lunch. That's good.
But quickly, how do we see it in real life? This is an example. So if you look over here, could you please maybe increase the brightness or change it to white mode?
We can change it to white.
This is something called Google Colabs. Do you guys know Google Colabs? Yes, right?
Yes.
If you don't know, you can access Google Colabs by searching online. It is a platform that will allow you to run machine learning code. You can use the cloud GPU. So that's what we use here. This is our first project, face mask detection. Very simple, real-life application, COVID. Thousands of businesses and companies had this algorithm in their scanners that were set up to ensure that people in workplaces had their masks on. Now what I want to quickly show you is the first step. Look what we're doing over here. Can you guys see what we're doing? It says from TensorFlow.Keras import. What is this? Importing libraries and tools. Remember I told you about TensorFlow.Keras? Where do I get these tools? You need to import them. This is all written in Python code. This is the first step.
Okay, let's move to our next step. Let's scroll down.
So that So I'm importing all of my functions. I'm importing a function for classification. I'm importing my deep learning layers, pooling, max2d. You don't need to worry about the names yet, but I'm telling you the tools on how to do this. Yes, please go down.
Please go down.
CV2. Have you heard of this library? CV2 is computer vision 2. If you want to make a machine learning model to do object recognition or detection, use CV2. You can note down some of these libraries.
Okay.
Yes,
You can go down. Now specifically in Google Colabs, if you want to import your data, you will need something called mounting your drive. So what you do in Google Colab is you save all your files in the drive and then just use files from the drive over your Google Colab. That's what we've done for importing data. Now after we import the data, what should we do? What's the next step in data processing?
What do we do after importing our
data? We have to process it.
Yes.
Right. Can you scroll down?
So here you're printing some images from your data. Please scroll down. I'm plotting them using which library?
Which library do we use to?
For visualizations. Yes, now.
That's right.
Please go down.
And again, we're plotting another sample image.
Please go down.
Scroll down. Scroll down.
Alright, so please stop here. Now, this is the process where you can see I am training my data on my model. Now, when you look over here, we have train size and you have your test size. This shows you how much data you are inputting into your model. So in this particular one, we have 1,332 samples and 333 testing samples. Your testing samples are always fewer than your training. You can follow an 80%, 20% split. 80% of the data for training, 20% of the data for testing. That's the usual procedure. Now, please go down.
Yes, please go down. Now, specifically for this project, we use something called a neural network. This is called a convolutional neural network. Now, I won't go in depth into what type of network this is, but this is the type of deep learning network. We've used a lot of layers, and for each layer, we specified the neuron. I talked about neurons in artificial neural networks, right? For each specific network, you can specify a certain number of neurons. And this is what we've done here. We're building our convolutional neural network.
So it's called a sequential model, the simplest deep learning model. Where do I find this? From the Keras library. All I'm doing now is making the different layers with a simple function model.add. In these layers, I'm specifying different parameters. Remember when I talked about optimization? These are the hyperparameters you will have to decide and optimize according to your model. Yes, please go down.
Please go down.
And yes, can you see, please go down. This is an example of my architecture of a model. Your deep learning model will have several different layers. Your convolution layers. Here we have something called CONV2D. This is convolutional neural network. If you want to build an image classification model, use a convolutional neural network. There are different networks for different tasks, but you don't have to start from scratch. They're all available in the Keras library from TensorFlow.
So probably after this session, I want you all to go and take a look at the different type of neural networks you can use.
Alright, so this is what we do. Evaluation. How do we do this? Through plots, through matplotlib. Please go down.
We talked about evaluation metrics, and here we have our training accuracy and testing accuracy in the graph. Please go up.
Okay. So this is an example of one of our projects. Let's move on to sentiment analysis.
Let's go to sentiment analysis, the second slide.
So do you all understand? This is the heart of any machine learning project, the code that you're running. But the tools that you use are only as efficient as the knowledge that you have. So whenever you're stuck, look for a library that has your functions. I told you I was doing a project on neuroengineering. There's a library called Signal in machine learning. It's from SciPy, and that lets me do machine learning for neuroscience. So it's not that every person who does a project invents every single algorithm. We use algorithms and modify them according to our project. Okay, this is for sentiment analysis. Do you know what sentiment analysis is?
So we talked about sentiment analysis.
If something is positive, negative, you guys know, okay, ratings. When you go to a restaurant, you read reviews, right? Now, what if I feed in a review to a model that says, wow, the food was amazing. What should it output? Positive, negative, neutral? Positive, yes. And if I input something, the food was very bland, I didn't like it. What should that be? Negative, yes.
That's good.
That's a sentiment analysis model, so many use cases. This is from Twitter tweets. And this uses 1.6 million tweets. Your data sets are usually very large. Yes, please go on. Again, there are different libraries for sentiment analysis. We can use word cloud, NLTK, Natural Language Processing Toolkit. This is going to be very useful for NLP-based projects. Please take a note of that. Yes, please go on.
Yes, please go down.
Again, this is all data pre-processing. In one review, if I have, yes, I liked the food. What is the most important word here for the sentiment analysis? Liked, yes. So all the other words are kind of unnecessary, right? In data pre-processing, what's happening here is, please go down. Scroll down. Yes, what's happening here is we are removing some of the unnecessary words. For example, the and. We're removing the words that we don't need, and we're also changing the words to lowercase. A lot of data pre-processing steps, replacing URLs with strings. That's what's happening here. Please scroll down.
Please scroll down.
Again, data pre-processing.
Please scroll down.
Here are all the words in the data set.
Yes, here we have something called the train test split, as we mentioned before. It's splitting our data set of 1.6 million tweets into the training set and the testing set. Now we've specified directly about the size of our test, and that's going to be 0.05. These are the exact parameters that you can alter in order to make your model more accurate.
Now if you look closely, what is the function I am using? This function is available in the library from scikit-learn, train test split. The function exists. All you have to do is fill in the parameters and your input according to your data. So don't worry about starting from scratch. You need to learn the functions. If you want to learn the code behind ML and AI, learn the libraries. That's where you have to start to master any project. Yes, please go down.
Yes. Please go down.
Again, there's a lot of vector transformation in NLP. Go down. Alright, please stay. Yes. So this is a logistic regression task. We're using the algorithm of logistic regression. Why am I using this? Quickly, I want to explain. We saw linear regression with house price prediction, right? Logistic regression is when you have classification tasks. What am I doing now? Sentiment analysis. Positive, negative, or neutral. Is this regression or classification? It's classification. Again, you might be confused here saying logistic regression, but yes, it's used for classification. And when your data is not linear, when it's not a straight line, but a curve. These are small concepts that you need to know to choose the right algorithm. Yes, please.
Yes.
Go down.
Please go down.
Again, have a look at our accuracy.
Now this is again one of our metrics, and we use something called precision. We call it F1 score. We had mentioned this on our slide previously. We also have something called the confusion makers. So in terms of evaluating your model, in order to find how accurate it is, you can use a visualization techniques like confusion matrix and a lot more other metrics too.
It shows you the false positives, how many predictions the model got right, how many they got wrong. It's a good visualization for your evaluation. These are things that you need to be doing to test the evaluation part of your model. Alright, can you give the next one?
Next one, can we go into house prediction?
Can we go to MNIST, the handwritten digit? Alright, quickly we'll go over this. And our last one is a chatbot. We'll quickly mention the library and algorithm used for that as well. So MNIST, have any of you heard of this data set, MNIST? This is the most popular data set that exists for machine learning. It's on Kaggle. Please visit the Kaggle platform, create an account, and you can start doing projects. Very simple. We have handwritten digits, and the algorithm or the machine learning model recognizes these digits and converts them into a string. So for example, a handwritten image, a digit of 9, an image, it will produce the output of the number 9 in the form of a string. That's the basis of the algorithm.
So as usual, now we're importing all the libraries, and specifically if you take a look here, we're using TensorFlow. So TensorFlow is a project developed by Google. We're also using the Keras data set. Now again, after importing all the modules, we again have the same train test split that we had discussed before. So the MNIST data set, it consists of images like these. They're all in grayscale and they're all handwritten. Now the image has pixels, right? So that's why you can visualize the image in the form of pixels and a grayscale.
Again, can you see we're doing the same thing? Splitting our data, this is data segregation. We split it into our training set and our testing set. The functions are already available for this. Now we can also visualize the training, the amount of data in our training set, the amount of data in our test set.
So you can see here we have 60,000 images for training and 10,000 images for testing. Please can you scroll down?
Alright, again, this is the model. So in every machine learning project, you saw the start we import, data pre-processing, and then do any other manipulation, then we get to the model. Again, sequential model, the simplest deep learning model you can get from the Keras library. We are adding different layers. If you see things called activation, don't worry, these are things called activation functions. These are hyperparameters that are going to affect your model accuracy. Again, the only way to know which is the best is to experiment. Alright,
so again, now we're plotting the model summary. This is the model architecture.
So we have 218,000 parameters in this model. When you're trying to build a large-scale application, you are going to deal with a lot of data. It is going to be computationally intensive. So Harpreet and I have already run this code. But if you're running your data, it's going to take a lot of time to get through each epoch. We call it an epoch. The duration it takes to train a whole batch size. And we call that an epoch. It takes about, let's say, 6 to 10 minutes per epoch with large data sets. So don't worry, your model is working, but sometimes you need computational power and time. That's also going to affect the accuracy of your model.
Can you scroll down?
Okay, please scroll. 1 second. Here you see model.compile loss. And we call something called categorical cross entropy. Don't worry about the term. This is something we're using for our evaluation metrics. So all these different functions, terms that you see, they're all linked to the concepts we learned. It's the basic concept, but you're going to get more advanced terms and hyperparameters. That's all you need to learn. Once you understand the structure, the concept, and the model, you can easily build your own projects. Yes, so can you see the epochs that we train? This is a batch size. So we have our data split into batch sizes. We feed each one into the model. So it trains until it's done with all of the different batches.
So as you can see here, we have 5 epochs that we've trained the model on, and accuracy for each epoch as well.
Alright, and we're printing the error. So again, another evaluation.
So again, we're also printing the accuracy, and as you can see, our model is 95.2% accurate.
Please roll. Alright, so another good example of, now we're including new test data for the prediction. So this is during the step of evaluation, unseen data. You might achieve 95% accuracy, but what is the problem that we talked about? It starts with the letter O. O fitting, perfect. Don't think just because you got 97% accuracy that the model is accurate. You need to feed in unseen data. That is going to be the last step of your machine learning pipeline or your project.
Yes, can you scroll down? And as you can see, the tested data that we provided is the handwritten digit of the number 3, and our predicted value is also the number 3.
So you can see that the model has predicted this one correctly. Predicted value is 3, gives us a probability score of how confident it was in predicting each value. this is the heart of this project, and this is a simple image classification task, or image recognition task. Yes,
Let's bring up the chat box.
Alright, for the last one, so we talked about classification, regression, we saw image classification, we saw logistic regression. I want to show something about chatbots, very good application in natural language processing. For chatbots, we use something else, a very different algorithm. It's called a transformer. I'm not going to go into the depths, but please note down these terms. If you want to do a project involving a chatbot or a language model, you will need to use a transformer. Why were transformers developed? Okay, we have deep learning, we have neural networks. Why do we need something else called transformers? Because for chatbots, I'll give you a good example. Please scroll down.
Scroll down.
Again, very important, yes. Scroll down, please. Alright, please stop here. Can you look at this quick example? This is a chatbot without a transformer algorithm. It says, hello, are you a bot? I'm a bot. And it asks, are you a human? It says, I'm a bot. Yes. So you might find this funny, it's saying the exact same thing. Why? Because the machine learning model or traditional machine learning algorithms, even deep learning some neural networks, are not complex enough to capture the content. When you're having a conversation, what's there? Context, meaning. Language models need more complex information. That's why they created transformers, which are a type of algorithm. Now look, hello, are you a bot? No, I'm not a bot, I'm a real person. Are you a robot? Are you a human? Yes, I'm a human. Way more conversational, and it has memory. Please go on. Same thing that I mentioned, to have memory, to have context, and to understand complex information, they created transformers. If you want to create a chatbot, look into transformers.
So again, here we're using the pre-trained transformers, we're not creating our own one. We're really using a transformer from different sources. So as you can see here, we're already using a transformer that has already been trained before. You have a transformer called Dialog GPT, and this large language model has been already trained on a transformer. We're just utilizing the same large language model for this chatbot that we are developing.
One very important thing to understand is most of your models and algorithms are open source, which means that you can use them for any purpose you like. You have that license or the ability to use them. So the reason people are making these models, algorithms open source is because they want others to use the models, to improve the models, and to use it for real world applications. So these models are waiting for you to pick them up and to do a project with. So machine learning and AI can be a very large scale, but the thing is you just need to pick one area of interest, start from there, and see if you can build your own model. Please go down. Alright, please go up actually. Okay, let's look at the results. We've already trained and run this code. So we have our chatbot and we asked, why is the weather so gloomy today? Let's see what our chatbot says, because there is no sunshine. And it seems like a good conversation, but there is a catch. Does anyone see the anomaly here? There's a bit of a catch.
We have a response that's kind of abnormal over here.
Okay, I'll give you some time to read it if you can. Maybe the people in the front can read this. So let's read this out. Because there's no sunshine? Is it also because of the rain?
I guess, not sure. I'm going to get back to my car and get it now. Should I go outside while it rains? Paint yourself blue.
Alright, so the bot says something very unrelated. Paint yourself blue. This is very common. Again, a good example of the fact that you're not going to achieve perfect models for the first try. The reason we have so many different hyperparameters, the reason there's so much focus on optimization is because you're not going to get perfect output. So that's your task as a programmer, as a machine learning expert. You're going to work on improving these open source models. And that's why companies, even though they develop them, they're making it open source for you. You all know ChatGPT?
ChatGPT. That's also a large language model.
Yeah, it's a large language model that someone has created. But they've spent years programming a lot of data into it. So all of these tech innovations that you see around you, they're made by humans just like you and I. The only difference is they found an area of passion and they work towards it. So that's the only thing that you all have to do today. I know some of you said, I still need to learn. That's good. We want you to learn. Explore the different libraries. Explore the different tools. But the quickest way you can improve your skills is by doing real life life projects. So Harper and I, even though we're still in the 12th grade, but we didn't let that stop us. We worked on machine learning projects in eutrophication with satellite data. We worked on machine learning projects for detecting diabetic retinopathy. Harper also worked on a machine learning project to detect malaria, and he was actually a Google Code to Learn finalist. Have any of you heard of the Google Code to Learn contest? So that's the thing. There are so many opportunities for you. Online, there are hackathons. On Kaggle, there are projects and competitions. Please enroll yourselves in them to practice your skills, and you will find something that interests you. Alright, that's it.
That's it. So I think we've learned a lot in this session about artificial intelligence and machine learning. We did discuss a lot about the libraries that we can use and websites that we can refer to when we want to take a look at real-world projects on machine learning. And I know all of you have taken down all of these libraries and the websites that are going to be really useful for you when you want to perform your own ML projects.
Okay, who has an idea for a project? Or some sort of idea that they want to focus on? Any idea? Any interest? Please raise your hand. If you have an idea, just a thought, a single thought. How many of you have an idea? Okay, I think you're still thinking. By the end of today, you have how many hours? You have at least 9 hours until 10 o'clock from now. Will you have one idea at least? Yes, I see somebody saying yes. Can I hear a loud yes?
Can we hear louder yes?
Louder. The louder it is, the quicker you can go for lunch. Oh, no, no one
So now I
wants to
think
go
no one wants to go
lunch.
for
No one
lunch.
wants to go for lunch. Okay, I'm kidding. But please, at least by the end of today, put some thought. Have a notebook. Try to write down some ideas. I can do this. I can create a project in this field. This is going to help you in your career. When you go to get a job, if you want to work in the field of AI and machine learning, you can be the best candidate with 5 to 10 projects already done. You can post these projects on your LinkedIn page. This is going to help you excel as a person, as a programmer, and it's going to make you the best candidate for the interviewer who's going to meet you. So these are things that are going to help you out. And we hope that today's session has given you the tools and the information to do these things. But it all lies in how far you are willing to take this information. So the information is out with you, but we want you to use it. Use Fun Morning Club? Yes or no?
Yes or no? Can we hear louder yes?
All right,
That's good.
thank you so
Thank
much.
you. Thank you all so much.
Perfect timing. Thank you all so
Thank
much
you all so much.
for this amazing session.
I think you want to enjoy the session.
Now I know, very long session, 3 hours of you sitting here, so much information, but I hope it was useful. If you have any questions, you're free to ask us. It can be about anything, opportunities, different things you can work on. The floor is open. But thank you so much for your patience and your understanding. The floor is open for questions. If you have any, we'll be free to take them. If you want to share feedback about something that you learned from the session, how it has helped you, anything new, please, we want to know how much knowledge, insight you have gained. Please fill this over there. Being the Tamil base now, being the Kishona base now, it's completely fine. Any feedback? Teachers, you can ask the students if they have any feedback, any questions.
If you want to share any feedback, you can do that right now.
Anything that you want to say? Feedback to us, not your friends. Anything? Alright, we have
Please come
feedback.
up. Go ahead.
So first of all, thanks Harpit and Harpita. So for conducting this wonderful session, I learned a lot of things about. I didn't know much of these many tools, many websites. So it's very useful for us. Small question. So what's the meaning between AI?
Okay, we have a question. What's the exact meaning or the difference between AI and ML? Does someone want to come answer this? Because we discussed this. Does anyone want to answer the difference between AI and ML?
Does anyone want to answer this question?
Do you all know the difference? Okay, I know everyone knows, but they're not going to get up here. It's okay. So the difference between AI and ML, as we talked about, is AI is the umbrella term. So machine learning is a subfield under AI. So you can say that anything that deals with machine learning is artificial intelligence because it's a subfield. But under artificial intelligence, we have machine learning, we have deep learning, reinforcement learning comes under machine learning. So you notice that happen. So basically, AI and machine learning, AI is the umbrella term, machine learning is the subfield of the symbol.
Where do we use AI? Where do we use ML?
Okay, where do we use AI and ML? So as I mentioned, anything that is machine learning can be classified as AI. So if I'm talking about, I'm building an AI model to classify images and detect malaria. So from the stem images. People use AI as a broad term. But when they say AI, I can mean either machine learning or deep learning. So you understand. So it can be either one. If I want to say in a broad term, I say I use AI. But if I use machine learning, I would say I use machine learning. If I use deep neural networks, I'll say I use deep learning. So AI and machine learning, wherever there is machine learning, there is AI. The only difference is machine learning is a subfield.
So, thank you so much for. So, do you have any other questions?
What are those? Yeah, I can ask some questions.
Guys, one of your own students is asking.
Yeah, if you have any questions, you can ask us now.
So he's taking over the stage now. Thank you for that confidence.
Thank
We
you.
needed that. Any other questions?
Do you have any other questions? It doesn't have to be related to artificial intelligence or machine learning. We just want you to ask any question. Okay, do we have a question?
Okay, I think we have another
We have
question.
another question.
Yeah.
Yeah, please come up.
Now, the people coming up here are not just coming up to answer or ask questions. They have the confidence to come up on stage. Yes.
Yes.
Did anyone hear his question? Question another.
Did everyone hear his question?
He asked a very nice story.
How do you know this much and how like you can do this much computer?
Okay.
Sure. Thank you so much for this question. This is about our entrepreneurship journey. He wants to know how did we become entrepreneurs?
Okay, I think we have a really long story about that. We all started from the age of 2. Harpreet and I were really interested in spelling and the language competency. We took part in a competition in Australia called the Great Australian Spelling Competition. And it was a national spelling competition that was showcased in Australia for about 6 months. Now on this competition, Harpreet and I were showcased as an inspiration to the entire world. We got a lot of popularity and fame on this competition. It was an experience where we could actually showcase our knowledge that we had learned about the spelling and language competency. Then we decided to migrate to India because we wanted to share this knowledge with students who needed them the most. Then the very next day when we came to India in 2016, we visited Hindustan International School and gave a model spelling workshop. We also did a motivational talk at Hindustan International School. From that day onwards, Harpreet and I had visited 200 plus schools all across India over the last 8 years. We do a lot of model spelling workshops, we do motivational talks, where we make students come up to the stage and talk about various topics. We help upskill them with the crucial life skills and the leadership skills they need in the 21st century. Now, in a lot of our sessions, we realized that the students were so enthusiastic and motivated to take part in our sessions. They were so excited to come onto stage. But there was a certain skills gap between students. Now, the skills gap I'm talking about is in terms of life skills. Some students had the fear of public speaking. They had the fear of coming onto stage in order to pronounce a word or to talk about their favorite topic. Now, this is why we founded our edtech company called ClassMinds. It's called ClassMinds. We've been running ClassMinds for about 3 years now. We kicked it off in 2019. Over the past 3 years with ClassMinds, we've helped impact over 8,000 students from 50 plus countries around the world. Basically, what we do in ClassMinds is we help students enrich their 21st century life skills using innovative approaches and the right approach to learning. So through ClassMinds, we have a spelling competition called Spellathon. Plus, Harpreet and I also run a lot of courses for students all around the world about leadership, communication, and language.
So that is how we became EdTech entrepreneurs. And apart from ClassMinds, we also run Astrologic.ai that was used to develop the educational resources like our ClassMinds app, And we're still working on more modules specifically for the education sector, focused on using AI for personalized learning. So we're working on a vocabulary app, something that helps students learn independently, because we realized that was an important skill. Apart from astrologic.ai, we also run a social movement called Youth Inspire Talks. That's one of the reasons we're actually here today. We've been to hundreds of colleges, institutions, even government schools, where we make sure to spread literacy on crucial global topics, including technology, environmental literacy, climate change. Harpan and I are the youth ambassadors of Exnora International. I'm not sure how many of you've heard, it's a reputable environmental organization. We focus on climate change, literacy, and all. So that's how our journey happens.
That's how so. Thank you.
Alright, thank you so much
Thank
for
you so
that
much.
question. That was wonderful. Any other questions before we break for lunch?
Do you have any more questions or feedback for us?
Alright, I think we are done. Alright, thank you so much everyone for this
Thank you so much everyone for attending today's session.
A huge round of applause for yourselves for sitting through. And I saw so many people taking notes, so many people who are actually participating interactively. We hope that this small session, it's only 3 hours, we can keep going on and on, but we hope this leaves a spark and some insight that you can carry with throughout the rest of your time at college and in the future. Thank you so much.
Thank you so much everyone. I think before everyone breaks for lunch, we'll all have a group picture together.
Okay, I think we can join everyone and everyone comes up. So, okay, can we take a group picture? Guys, please say yes or no for this. Okay, did I hear a no from someone?
Yeah.
Okay, just kidding. Alright, thank you so much. And
அப்படியே பின்னாடி வாங்கிருங்க.
thank you all so much.
Thank you all.
Alright, huge round of applause for these people. saw you take your certificates. Thank you all so much for attending this program, taking all of your time and your effort, and also we hope that it has inspired you and left you with a lot of knowledge. Thank you to the team for putting this together. It's a very well organized session. Even though there were delays, we quickly fixed them. Thank you so much. To the technical team working over here as well. Give them a applause, please, together.